What does it mean to be alive? As you rest here, in the quiet of this room, your body is performing billions of tiny, silent miracles every single second. You might feel perfectly still, wrapped in the warmth of the moment, with only the slow, steady rise and fall of your chest to mark the passing of time. But beneath that feeling of profound stillness, you are a vast, complex universe all on your own, humming with a quiet, persistent rhythm. General biology is simply the story of that rhythm. It is not merely a collection of terms or distant concepts. It is the deeply personal story of how the very small, almost invisible pieces of matter come together to form everything that grows, breathes, and dreams. It is the story of the towering, ancient redwood trees whose roots drink from the deep earth, the silver fish that dart through the cold currents of the ocean, and the quiet beating of your own heart in the dark. Consider the sheer stillness of a stone resting by the side of a road. It is made of matter, just as you are. It has weight, it takes up space, and it endures the wind and the rain. But it does not grow. It does not heal when it is broken, and it does not draw warmth from the sun to fuel its own internal fires. Now, consider the materials that make up your own body. If we were to break them down into their most basic forms, we would find nothing particularly magical or rare. We would find carbon, the same dark element left behind in a wood stove. We would find oxygen, the invisible gas swirling through the atmosphere. We would find calcium, hydrogen, and a few pinches of other common elements scattered across the earth. On their own, laid out on a table, these elements are entirely lifeless. They are just dust and air. Yet, something extraordinary happens when they are brought together in a very specific, perfectly balanced choreography. They wake up. The carbon, the water, and the breath weave themselves into a tapestry that can suddenly move, heal, think, and feel. You are a temporary, beautiful gathering of these ordinary elements, arranged in a way that allows you to experience the universe. Biology is the gentle study of that arrangement. It asks how the lifeless dust of the earth learns to stand up, look around, and wonder about its own existence. To begin to understand this, we have to let our minds drift inward, leaving the large, familiar world of arms and legs, skin and bone, and moving deeper. Imagine you are standing outside a grand, sprawling house late at night. From the street, the house looks entirely dark and completely still. But if you were to walk up to the front door and listen closely, you would hear the subtle signs of activity. You would hear the low, steady hum of the refrigerator in the kitchen. You might hear the faint click of the furnace gently pushing warm air through the vents, or the quiet ticking of a clock in the hallway. The house is resting, but it is not turned off. It is actively maintaining itself, keeping the cold out and the warmth in. Your body is exactly like this house. As we zoom in, past the quiet surface of your skin, past the slow, steady flow of blood through your veins, we arrive at the microscopic rooms that make up the house of your body. We arrive at the fundamental building block of all living things, the cell. When you hear the word building block, it is easy to picture a hard, rigid object, perhaps like a cold, sharp-edged brick in a wall. But a cell is nothing like a brick. It is not hard, and it is not dry. Instead, I want you to picture a single drop of morning dew resting softly on the curved edge of a blade of grass. It is heavy with water, shimmering in the light, held together by its own delicate surface tension. A cell is very much like that drop of dew. It is a tiny, soft, fluid compartment that holds an entire, microscopic ocean within it. Every living thing you have ever seen, touched, or known is made of these tiny, soft droplets. Some organisms, like the invisible yeast that makes a loaf of bread rise, or the glowing algae that light up ocean waves at night, consist of just one single cell. They drift through the world alone, entirely self-contained, handling all the duties of life within that one fluid space. You, however, are a vast, collaborative society. You are composed of trillions of these cells, all resting against one another, communicating in soft chemical whispers, sharing the work of keeping you alive. Inside each one of these cells, there is a miniature world. It is a world suspended in a clear, jelly-like fluid where everything has a purpose and nothing is wasted. Even right now, as you drift closer to sleep, the interiors of your cells are bustling with quiet, organized purpose. They are taking in tiny sips of nutrients, gently repairing microscopic wear and tear, and generating the quiet warmth that radiates from your skin. They do this without asking for your attention or demanding your effort. They are the faithful, silent caretakers of your existence, working tirelessly in the dark so that you can simply be. But for this tiny, soft droplet to survive, to maintain its delicate internal harmony, it cannot simply bleed into the world around it. It needs a boundary. It needs a way to separate the safe, carefully balanced ocean inside from the chaotic, ever-changing environment outside. If the cell is to be a sanctuary for life, it must draw a line between what is self and what is everything else. And with that understanding quietly in place, we're naturally led to ask what exactly forms the outer edge of this tiny drop of life. That outer edge is called the cell membrane. When we think of a border or a protective wall, our minds naturally drift toward the things we build in our own lives. We imagine solid brick walls, tall wooden fences, or rigid sheets of glass, things that are hard, unyielding, and meant to stand perfectly still against the wind. But nature rarely works in straight lines or stiff materials. The cell membrane is nothing like a brick wall. It is wonderfully soft, constantly moving, and deeply fluid. Picture a large, beautifully delicate soap bubble gently floating in the air, its surface constantly shimmering, catching the light as colors swirl slowly across its curved face. The cell membrane is very much like that bubble. It is a living, breathing boundary that separates the quiet, protected ocean inside the cell from the vast and busy world outside. To truly appreciate the elegance of this border, we have to look at what it is made of. The entire structure is built primarily from fats. You might already have a sense of how fats behave from your own experience in the kitchen. If you have ever poured a few drops of olive oil into a bowl of water or shaken up a bottle of vinaigrette dressing, you know that oil and water simply do not mix. The oil naturally pulls away from the water, gathering itself into perfectly smooth, golden droplets. This happens because the fat molecules are trying to hide from the water, clustering closely together for comfort. Your cells use this exact, simple principle of nature to build their protective walls. The membrane is made of a brilliant, double-layered sheet of specialized fat molecules. Imagine millions of tiny shapes, almost like microscopic balloons, where the round balloon part loves water, but the strings hanging down absolutely despise it. To solve this problem, these tiny shapes line up in two identical rows, facing each other. The water-fearing strings hide in the middle, safely sandwiched between the water-loving balloon heads, which face outward to the environment and inward to the cell. This double layer creates a perfect, continuous sphere. It is a masterpiece of biology, assembled not by rigid glue or nails, but simply by the natural, quiet desire of these molecules to find their most comfortable resting place. Because it is held together only by this natural attraction, the cell membrane is completely fluid. It is not frozen in place. If you could see it up close, it would look like a slow, gently rolling ocean. The individual fat molecules are constantly trading places, slipping past one another like people smoothly making their way through a crowded room. This fluidity gives the cell an incredible resilience. If you push on a rigid brick wall too hard, it will crack and shatter. But if you were to gently press against the cell membrane, it would simply yield, bending softly around the pressure before flowing right back into its original, perfect shape. It is a boundary that survives not by resisting the world, but by gracefully moving with it. But this shimmering fluid sphere cannot be completely sealed off. If it were completely closed, the cell would be a tiny, isolated vault, unable to eat, breathe, or communicate. Instead, the cell membrane acts much more like a well-managed, bustling border town. Floating within that sea of fat are larger, more complex structures made of protein. You can picture these proteins like wooden ships drifting in the oil, or perhaps like intricate, specialized gates set into the boundary wall. These gates are the customs agents of the cell, and they are extraordinarily careful about what they allow to cross the border. The cell needs a constant supply of fresh materials to survive, much like a city needs delivery trucks bringing in food and supplies. But it only wants the right materials. For some things, the journey across the border is effortless. Think of the oxygen you just breathed in. It is so small and so vital that it doesn't even need to wait in line at the gates. It simply slips directly through the fluid fat layer, passing from the outside world into the cell like a cool, gentle evening breeze, blowing effortlessly through a fine mesh screen door. It requires no energy, no thought, and no effort. It is a completely passive, natural process, driven only by the universe's desire to spread things out evenly. But other things are simply too large or too uniquely shaped to slip through the screen door. When you eat a piece of fruit, your body breaks it down into simple sugars. The cell desperately needs that sugar for energy, but the sugar molecule is too big to just drift across the border. It needs a special entrance. So, the sugar approaches one of those large protein gates. The gate checks its shape, recognizes that it is a friend, and slowly opens, gently escorting the sugar into the warm interior of the cell. Sometimes, the cell must do things the hard way. There are moments when the cell needs to gather resources that are scarce, pulling them inside even when the space is already crowded. Imagine a ferry attempting to carefully pull a heavy car across a river, pushing hard against a strong, opposing current. It takes a deliberate, conscious effort. The cell uses its own hard-earned energy to power certain protein gates, forcing them to pump essential minerals and nutrients inward against the natural flow of things. And just as this border allows fresh supplies to enter, it also handles the city's exhaust. As the cell works and lives, it creates waste. This waste is carefully guided back to the border, loaded into special outward-facing channels, and gently pushed back out into the bloodstream to be washed away. Beyond just moving supplies in and out, this quiet border town serves one more vital purpose. It listens. Your cell membrane is covered in tiny, delicate structures that reach out into the fluid around them like soft antennas. These are receptors, the eyes and ears of the cell. They wait patiently for messages from the rest of your body. Imagine walking up to a friend's house to deliver a message. You don't need to walk all the way into their living room to tell them. You simply stand on the porch and ring the doorbell. When a chemical messenger from your brain or your heart arrives at the cell, it doesn't usually go inside. It simply binds to the outside of one of these antenna proteins, effectively ringing the doorbell. The protein then changes its shape, sending a soft, silent echo of that message deep into the heart of the cell, telling it to grow, to rest, or to begin its daily work. It is a profound thought to hold as you rest here. Right now, in this very moment, you are made of trillions of these tiny, shimmering soap bubbles. Trillions of quiet border towns, each one flawlessly managing the delicate balance of what to let in, what to let go, and when to listen. They are doing this without your conscious direction, a vast, invisible rhythm keeping you perfectly tethered to life. It is a system of absolute, beautiful harmony, constantly maintaining the sanctuary within. So, if this fluid membrane is the border protecting the city, and the gates are managing the flow of life, we are naturally led to wonder what lies at the very center. What is being protected with such care? Where does the cell keep its oldest laws, its master blueprints, and the instructions for building every single gate in this sprawling town? That is what we'll gently explore next, as we travel inward to the deepest, most secure room of all. We left our journey at the busy, fluid border of the cell, where the shimmering membrane carefully manages the flow of life, deciding what may enter and what must be turned away. If you were to slip past those gates, passing gently into the interior of the cell, you would find yourself drifting through a clear, slow-moving fluid. This space is peaceful, yet deeply purposeful. Floating all around you are various tiny structures, quietly carrying out their specialized tasks. But your attention would inevitably be drawn away from the periphery and pulled toward the very center of this microscopic world. There, suspended in the quiet depths, rests a large, dense, and perfectly round sphere. This is the nucleus. If the cell membrane is the border protecting a bustling town, the nucleus is the grand, highly secure vault, sitting right in the center of the city. You might imagine a historic hall of records, the kind with thick stone walls, heavy oak doors, and a hushed, reverent atmosphere inside. Just like the cell itself, the nucleus is wrapped in its own protective envelope, a second, inner wall that keeps its precious contents entirely separated from the daily wear and tear of the cell's busy factory floor. This inner wall has its own highly exclusive security checkpoints, tiny pores that strictly govern what can pass in and out. It is the safest, quietest place in your entire body. As we imagine stepping through those heavy doors and entering the vault, we might expect to find a chaotic jumble of chemicals. But what we actually find is an archive of breathtaking order and profound value. Inside this library, there are no ordinary books, no paper files, and no hard drives. Instead, the vault holds incredibly long, delicate, winding threads of physical information. This is your DNA. It is the master blueprint of you. Everything you are, the color of your eyes, the natural texture of your hair, the exact shape of your heart, and the way your body responds to the world is written right here in these threads. To truly appreciate the beauty of this blueprint, picture the act of buying a piece of property to build a beautiful, custom home. You would hire an architect who would spend months drawing up the master plans, detailing every single pipe, every wooden beam, and every electrical wire. Those plans are irreplaceable. Your DNA is exactly like those architectural plans, but for a project vastly more complex than any house. And just as you would never take the original, fragile, hand-drawn blueprints out into the rain and mud of the construction site, the cell never allows your original DNA to leave the nucleus. It remains safely locked away in the dark, resting securely. If you were to gently pull one of these threads out and look closely at it, you would not see complex mathematical symbols or a confusing language. You would see a shape of quiet, perfect elegance. Picture a long, flexible ladder, like a rope ladder you might use to climb up to a treehouse. Now, imagine taking the top of that ladder and twisting it slowly, so the two sides wrap around each other in a graceful, endless spiral. This is the famous double helix. It is a shape that is both beautiful to imagine and structurally flawless, allowing a massive amount of information to be packed into an incredibly tiny space. And it truly is a massive amount of information. If you were to take the twisting threads of DNA from just one single invisible cell in your body and stretch them out end to end, the thread would be roughly 6 feet long. To pack a 6-foot-long thread into a microscopic sphere without tangling it requires a masterpiece of organization. Your body solves this problem exactly the way you might solve the problem of a long, unwieldy garden hose or a tangled kite string. It uses spools. Inside the nucleus, the DNA is meticulously wrapped around tiny, specialized proteins that act just like wooden spools. These spools are then stacked neatly together, gathering the endless thread into dense, compact bundles. It is a marvel of biological packing, ensuring that the library is perfectly organized, with every single chapter exactly where it needs to be. But how do these twisting threads actually hold information? How does a physical string know how to build a human being? If you look closely at the rungs of that twisted ladder, the steps connecting the two sides, you will find the secret. Each rung is made of two chemicals, reaching out and holding hands in the middle. There are only 4 types of these chemicals in the entire structure. Just 4 simple shapes, repeating over and over again along the 6 feet of thread. Think about the English language. With just 26 letters, we can write the entire history of the world, compose sweeping symphonies, draft complex legal documents, and write love letters. The alphabet of life is even simpler. It has only 4 letters. The specific order in which these 4 letters are arranged along the ladder spells out the exact recipes for every single part of your body. It is much like the binary code used to run all the world's computers and smartphones. All the sprawling internet, all the complex software, all the video and audio is ultimately built from just 2 numbers, ones and zeros, arranged in endless, specific patterns. Your body is the ultimate software, written in a chemical code of 4 letters, quietly sitting in the dark vault of the nucleus. Because this master code never leaves the vault, the cell has developed a beautiful system for sharing the instructions with the rest of the body. When a part of the cell needs to build something, say, a new piece of muscle, or a protein to help digest your dinner, a tiny chemical machine enters the nucleus and finds the exact chapter in the DNA library that holds that recipe. It gently unzips that small section of the twisted ladder, just enough to read the letters. Then, it creates a temporary, single-sided copy of that exact recipe. You do this in your own life all the time. If you have a massive, heavy, delicate antique cookbook resting on a stand in your library, you don't drag it into the messy kitchen to bake a cake. You take out your phone, snap a quick picture of the page, and take the digital copy into the kitchen. The cell does exactly this. It makes a fragile, temporary copy of the DNA's instructions. Once the copy is made, the master DNA quietly zips back up, untouched and pristine. This temporary copy, carrying the precious instructions, then floats away from the tangled threads. It drifts toward the heavy doors of the nuclear envelope, slips smoothly through one of the tiny security pores, and leaves the quiet vault. It travels out into the wider, busier world of the cell, heading toward the biological construction sites where the actual building takes place. The master blueprint remains behind, safe and secure, waiting patiently for the next time it is needed. It is a system of profound care and preservation, protecting the unbroken chain of information that makes you who you are. But a blueprint alone, no matter how detailed, cannot build a house. It requires workers, and it requires energy. Without power, the plans are simply resting in the dark. Let's set that idea down now, fully formed, and let our attention drift toward how the cell actually powers the building of these incredible structures, fueling the quiet fire of life within you. A blueprint alone, no matter how elegant or detailed, cannot build a house. If you were to lay the most perfect architectural plans on a completely empty plot of land, nothing would happen. To turn those quiet drawings into physical reality, you need 2 things: materials and a tremendous amount of energy. The cell is exactly the same. We have seen the master blueprint safely stored in the grand library of the nucleus, and we have watched as a delicate copy of the instructions floated out into the wider cell. But if the cell were dark and cold, that instruction manual would be useless. Let us set the library down now, fully formed in our minds, and let our attention drift away from the center of the cell, moving gently through the clear, bustling fluid. We are looking for the source of the cell's power. We are looking for the engines. Scattered all throughout this fluid are hundreds, sometimes thousands, of tiny, oval-shaped structures. These are the mitochondria. They are the dedicated power plants of the cell. If you were to encounter one in this microscopic world, it would look a bit like a smooth, plump jelly bean, or perhaps a small, rounded submarine, silently drifting through the waters. but their smooth outer appearance hides an incredibly complex and beautiful interior architecture. Imagine taking a large, thick winter blanket and trying to stuff it inside a much smaller sleeping bag. To make it fit, you would have to fold the blanket over and over again, creating layers upon layers of soft, overlapping folds. This is exactly how the inside of a mitochondrion is structured. Beneath its smooth outer shell, there is a second, inner skin that is deeply folded back and forth upon itself. Nature uses this beautiful folding technique whenever it needs to fit a very large surface area into a very small space. Think of a long, winding mountain road that switches back and forth to cover a steep, compact distance, or the gentle, undulating folds of a heavy curtain. The mitochondrion is folded in this way because the entire surface of that inner blanket is studded with thousands of microscopic, highly sophisticated engines. The more folds there are, the more engines the cell can pack into this tiny space. And these engines run constantly, day and night, without ever needing you to consciously think about them. To understand how these engines work, we have to look closely at what they are burning. When you sit down to enjoy a warm, satisfying meal, perhaps a bowl of oatmeal in the morning, or a piece of fresh bread, you are not just eating flavor and texture. You are eating captured energy. Long before that food reached your plate, a plant sat quietly in the dirt and absorbed the radiant, blazing light of the sun. The plant took that raw, chaotic solar energy and locked it safely away into chemical bonds, creating sugars and starches. When you eat that plant, or when you eat something that ate that plant, you are taking in that trapped sunlight. Your digestive system patiently breaks the meal down, dismantling it piece by piece until it becomes a stream of tiny, simple molecules. These molecules are absorbed into your blood and carried on a gentle current to every single cell in your body, finally arriving at the smooth, waiting doors of the mitochondria. But there is a problem. The energy locked inside those food molecules is too large and too raw for the cell to use directly. It is like trying to pay for a simple cup of coffee with a solid, heavy bar of gold. The gold holds a tremendous amount of value, but it is not a usable currency for a small, everyday transaction. The cell needs a currency it can spend easily, something small, quick, and universally accepted. This is the brilliant, specialized work of the mitochondria. They are the ultimate biological currency exchange. They take the large, solid gold bars of energy from your food and feed them into the intricate machinery resting on those folded inner walls. Inside, a quiet, invisible fire begins to burn. It is not a fire of smoke and open flame, but a highly controlled chemical furnace. Through a breathtakingly elegant series of steps, the engines dismantle the food molecules completely, releasing the trapped sunlight from the ancient plant. They use this released power to charge up millions of tiny, independent, reusable batteries. In biology, we call these batteries ATP, but you can simply think of them as crisp, $1 bills of cellular energy. These tiny batteries are the perfect currency. Once fully charged and ready, they float away from the mitochondria and drift out into the cell. Whenever any part of the cell needs to do any work, whether it is hauling a piece of cargo, copying a strand of DNA, or flexing a muscle fiber, it uses one of these little batteries to power the action. The battery releases its spark of energy, becomes empty, and then gently floats right back to the mitochondria to be recharged all over again. It is a flawless, endlessly recycling loop of power. But a fire, even a biological one, needs oxygen to burn. When you light a candle and place a glass softly over the top, the flame quickly flickers and dies as the air is consumed. The microscopic furnaces inside your mitochondria are no different. This is the entire reason you breathe. Right now, as you lie here, your chest is rising and falling in a slow, steady rhythm. With every breath in, you are pulling fresh oxygen from the world and sending it deep into your lungs. From there, it enters the blood and travels straight to the mitochondria. The oxygen sits at the very end of the engine's assembly line, acting like a gentle, necessary magnet. It pulls the entire energy-making process forward, catching the exhausted, broken-down pieces of your food at the end of the line. When the oxygen combines with these used-up remnants, it forms something entirely new, incredibly simple, and wonderfully harmless: pure water and a little bit of carbon dioxide. The carbon dioxide is gently swept away by the blood, carried back to your lungs, and released back into the world with every quiet exhale. You breathe in the vital spark, and you breathe out the gentle exhaust of your own internal engines. It is a perfect, continuous exchange with the world around you. As these tiny power plants hum with activity, converting food and air into life, they generate a byproduct that you are very familiar with. Like any machine that works hard, from the engine of a car to the back of a busy refrigerator, the mitochondria release heat. The warmth that you feel beneath your blankets right now, the heat that radiates softly from your skin, is not magic. It is the physical exhaust of trillions of microscopic fires burning silently inside your cells, keeping your body at a perfect, life-sustaining temperature. There is one more beautiful secret resting inside these power plants, a deeper layer to their story. Unlike any other part of the cell, the mitochondria possess their own private, separate piece of DNA, completely independent of the master library in the nucleus. And because of the unique way human reproduction works, you did not inherit this mitochondrial blueprint from both of your parents. You inherited it entirely, perfectly intact, from your mother. She received her cellular engines from her mother, who received them from hers, stretching back in an unbroken, continuous line of maternal energy through the deep oceans of human time. The fires burning inside you tonight were sparked by a flame passed down through countless generations of women. Even as you rest, seemingly perfectly still, your body is consuming massive amounts of power. Your brain is silently sorting the memories of the day. Your heart is softly pushing blood through thousands of miles of vessels, and your cells are quietly repairing themselves. All of this is fueled by the brilliant, folded engines drifting in the dark. And as these tiny, rechargeable batteries float away from the mitochondria, carrying their precious cargo of refined energy into the wider cell, we might wonder exactly what the cell is using this power to create. The blueprints have been read, and the power has been generated. Now, the physical construction must begin. What exactly is this power being used to build? That is what we will gently explore next. We have watched the master blueprint carefully copied in the quiet vault of the nucleus, and we have seen the brilliant, folded engines of the mitochondria burning quietly to produce usable energy. In a human city, when the architectural plans are finalized and the electricity is finally turned on, the heavy machinery begins its work. The cranes lift, the drills turn, and the physical structure of the city is built. In the microscopic world of your cells, the energy and the instructions converge for one primary, magnificent purpose: the creation of proteins. When we hear the word protein in our everyday adult lives, our minds naturally drift to the kitchen or the gym. We think of protein as a category of food, a piece of fish, a handful of almonds, or a shake we drink after a long run to help our muscles recover. We are taught that it is an essential part of our diet, something we consume to stay strong. While this is entirely true, it only tells the very end of the story. To truly understand biology, we have to gently set aside the image of food on a plate and shift our perspective. In the bustling, fluid world of the cell, a protein is not simply a nutrient. It is a physical, three-dimensional machine. Proteins are the invisible workforce of your body. They are the engines, the scissors, the scaffolding, the sensors, and the transport ships that do almost all the physical work of keeping you alive. To understand how the cell builds these brilliant little machines, we must first look at their raw materials. Just as a heavy iron bridge is built from individual steel beams and rivets, every protein is built from smaller, simpler pieces. These pieces are called amino acids. You have likely heard that term before. perhaps printed on a supplement bottle, but you can simply picture them as a collection of specialized building blocks. Imagine a beautifully crafted set of wooden beads, the kind you might find in a high-end jewelry workshop. But in this biological workshop, there are exactly 20 different types of beads available. Each of these 20 beads has a completely unique personality. Some are naturally drawn to water, while others desperately want to hide from it. Some carry a tiny positive electrical charge, while others are negative. Some are large and bulky, while others are incredibly small and flexible. Every single protein in your entire body and in every living thing on Earth is made by stringing together these 20 specific types of beads in different arrangements. Let us return to that delicate, temporary copy of the blueprint that we watched slip out of the nucleus earlier. As it drifts into the main fluid of the cell, it approaches a tiny, dedicated workstation. You can picture this workstation as a small, highly efficient reader, much like the scanner at a grocery store checkout or a vintage tape player. The blueprint gently threads itself into this reader. Now, the energy from the mitochondria is put to use. Powered by those tiny rechargeable batteries we just explored, the workstation begins to read the instructions, letter by letter. The blueprint tells the workstation exactly which of the 20 beads to grab first. It pulls that specific amino acid from the fluid around it and holds it in place. Then, it reads the next part of the instruction, grabs the second required bead, and clicks it firmly onto the first. It does this over and over, incredibly fast, building a long, customized chain. This chain might be 100 beads long, or it might be thousands of beads long, all arranged in the exact, specific order dictated by the ancient recipe held in your DNA. But a long, straight chain of beads is just a string. It cannot do any real work. If I handed you a straight piece of metal wire, you couldn't use it to cut paper or drive a screw. For a tool to be useful, it must have a shape. This is where the true magic of the protein happens, a process so elegant that scientists still marvel at it today. As the long chain of amino acids slips out of the workstation, it does not stay straight. Remember that every single bead in that chain has a different personality. Almost instantly, the beads begin to interact with one another. The positively charged beads pull violently toward the negatively charged ones, like magnets snapping together. The beads that fear water quickly fold themselves tightly inward, trying to hide deep in the center of the structure, while the water-loving beads enthusiastically push their way to the outside edge. Without any conscious direction, driven entirely by the natural forces of attraction and repulsion, the long string begins to contort. It bends, twists, spirals, and crunches in on itself. In a fraction of a second, the loose chain of beads completely collapses into a highly specific, intricate, three-dimensional shape. Imagine taking a long piece of memory wire and gently dropping it onto a table, only to watch it instantly and flawlessly fold itself into a perfect, working pair of miniature pliers, or a delicate, spring-loaded trap. That is what a protein does. The shape it folds into is entirely determined by the exact order of the beads, which was entirely determined by your DNA. And in the world of biology, shape is absolutely everything. The physical shape of the folded protein completely defines what its job will be. Some of these chains fold into long, incredibly strong, braided cables. These are structural proteins, like collagen and keratin. They are the invisible steel beams that give your skin its elasticity, hold your bones together, and slowly push outward to form your hair and nails. They are designed for pure endurance and strength. Other chains fold into shapes with tiny, specialized pockets, acting like perfectly crafted locks waiting for a specific key. These are the receptors we saw earlier, sitting on the cell membrane, waiting to catch a passing message from the brain. Still others fold into shapes resembling microscopic scissors or hammers. These are called enzymes. Their job is to actively build things up or take things apart. When you eat a piece of bread, it is these precisely folded protein scissors floating in your digestive system that physically clip the complex starches apart into simple sugars. Without them, the meal would sit untouched. There are even proteins that fold into tiny walking motors. If you were to look close enough, you could watch them literally stepping foot over foot along the internal scaffolding of the cell, carrying large sacks of cargo from one side to the other, powered by the energy of the mitochondria. Every breath you take is captured by a specialized protein called hemoglobin, folded into the perfect shape to cradle a molecule of oxygen. Every flash of light that enters your eye is caught by a protein resting in your retina. Every thought you have, every movement you make, and every gentle heartbeat sustaining you right now is the direct result of millions of these tiny, beautiful machines folded into perfect shapes, working quietly in the dark. You are a masterpiece of this continuous, silent engineering. The cell gathers the dust of the earth, reads the ancient plans, burns the gathered sunlight, and folds the pieces into the machinery of life. A moment ago, we ended with the idea of a single cell working incredibly hard just to maintain this delicate internal balance and survive. But life is not simply about survival. It is about continuation. Let's pick up that thread right where we left it and ask what happens when that cell reaches the end of its solitary journey, when it has grown as much as it can, and the time comes for it to share the burden of existence. That is what we will gently explore next. A moment ago, we ended with the idea of a single cell working incredibly hard just to maintain its delicate internal balance. We watched it gather energy, read its ancient instructions, and build the tiny folded machines that keep your body humming. But the story of life is never truly about standing entirely still. There comes a moment in the quiet, microscopic life of a cell when it reaches the peak of its solitary journey. It has gathered all the nutrients it can hold. It has grown as large as its fluid membrane will comfortably allow, and the time arrives for it to do something profound. It prepares to share the burden of existence. This is the art of cellular division, a process of deeply patient and flawless duplication. You might wonder why a cell doesn't simply live forever in its perfect, isolated little sphere. Think about a small, highly successful local business, perhaps a bakery, or a quiet neighborhood restaurant. The owner works day and night, managing the inventory, serving the customers, and keeping the place immaculate. Eventually, the business becomes so successful and so full of demand that one person and one small building can no longer handle the pressure. The space is too crowded, and the supplies cannot be moved fast enough from the back room to the front door. The only way for the business to survive and continue thriving is to open a second location, exactly like the first, to share the daily work. Your cells follow this exact, elegant logic. As a cell grows larger, its deep center becomes too far away from its outer border. It takes too long for the fresh oxygen and nutrients to travel from the membrane all the way into the nucleus. To stay efficient, to stay vibrantly alive, the cell must divide. This silent replication is happening inside you right now, millions of times over, even as you rest and listen. It is the process that allows the skin on your hands to gently replace itself after a long week of work or gardening. It is how a small scratch on your arm slowly fades and heals, seamlessly knitting itself back together over a few days, without you ever having to consciously direct the repair. It is the continuous, invisible tide of physical renewal that keeps your body whole, constantly trading the old and tired for the fresh and new. But dividing a cell is not as simple as cutting an apple in half. If you cut an apple in half, you are left with two smaller, incomplete pieces. When a cell divides, it must create two completely whole, perfect entities. And so, the most critical step in this entire process happens before the cell even begins to change its physical shape. The cell must duplicate the grand library. It must copy its DNA, ensuring that the new cell will have the exact same master blueprint as the original. Imagine that twisting, graceful ladder of information resting safely inside the dark vault of the nucleus. To copy it, the cell employs a set of specialized, gently moving proteins. They travel down the very center of the ladder, quietly unzipping it, separating the left side of the rungs from the right side. It is a delicate process, much like slowly opening a very long, finely crafted zipper on a piece of luggage. Once the two halves of the ladder are exposed to the open fluid, the cell reaches into its reserves and begins to build a new partner for each half. Because the four chemical letters of the DNA alphabet only pair together in very specific, loyal ways, the cell can look at just half of the ladder and know exactly how to rebuild the missing side. By the end of this incredibly patient process, the single twisting thread has become two identical, intertwined threads. The master blueprint has been flawlessly duplicated. Nothing is lost, and nothing is left to chance. Now the cell faces a purely physical problem. We imagined earlier that the DNA inside a single human cell is incredibly long, roughly 6 feet of fragile, winding thread packed into a microscopic space. If the cell simply dissolved its library and tried to pull itself apart with all of that loose thread floating around, the delicate information would become hopelessly tangled, knotted, or torn. To solve this, the cell does exactly what you would do if you were preparing to move to a new home across town. You wouldn't try to move by carrying messy armfuls of loose shirts, stray coffee mugs, and scattered books out to the car. That would be chaotic and risky. Instead, you would carefully fold your clothes, wrap your delicate items, and pack everything tightly into sturdy, organized moving boxes. The cell packs its DNA in the exact same way. It takes those long, newly copied threads and winds them up tighter and tighter, coiling them into thick, dense, microscopic packages. We call these tightly wound packages chromosomes. You can simply think of them as the sturdy moving boxes of the biological world. They keep the delicate instructions perfectly safe and highly organized for the momentous journey ahead. Once everything is carefully packed into these dense chromosomes, the grand vault of the nucleus softly dissolves, allowing the moving boxes to float freely into the open, fluid space of the cell. What happens next is one of the most highly choreographed, beautiful visual dances in all of nature. The cell casts out tiny, invisible cables from opposite ends of its outer edges. These cables act like gentle guiding tethers. They reach into the center of the cell, slowly feeling their way through the dark until they find the duplicated moving boxes, and they delicately attach themselves to the center of each one. With a slow, steady, and perfectly synchronized tension, the cables begin to pull. They slowly reel in the boxes, guiding one complete set of blueprints to the far left side of the cell and the exact identical set to the far right. It is a masterpiece of biological precision. There is no rushing, there is no sudden tearing or violent movement. It is just a quiet, deliberate parting of ways, ensuring that each new side of the room will have absolutely everything it needs to begin its own independent life. Once the two complete libraries are safely resting at opposite ends, the cell membrane, that soft, shimmering border of fat we explored earlier, begins to shift. Slowly, gracefully, the outer membrane starts to pinch inward directly at its center. It is exactly like taking a large, water-filled balloon and gently wrapping your hands around the middle, squeezing softly until the water is naturally forced into two distinct, rounded halves. The membrane sinks deeper and deeper into itself, creating a narrow bridge, until finally the two sides meet in the middle and softly fuse together. In that quiet, defining moment, the single drop of water parts into two. Where there was once a single, solitary cell, there are now two perfectly formed cells resting side by side. Neither one is the original parent, and neither is the child. They are true equals, a shared continuation of the exact same life. Almost immediately, they will both build a fresh, protective nuclear vault around their blueprints, unbox their tangled threads, and begin the quiet work of gathering energy and building proteins all over again. This solitary division is a miracle of survival, a way for life to sustain itself against the gentle wear and tear of time. But if every cell in your body simply divided and drifted away to live alone, you would not exist as you are. A human being is not a scattered, disconnected collection of solitary drops of water. Before we rest here, let me whisper where we're headed next, not to rush you, but to plant a seed in your mind about what happens when these millions of newly divided cells decide not to drift apart. What happens when they choose to stay together, learning to share their space, their resources, and their purpose to build something vastly larger and more capable than themselves? That is the beautiful story of our shared tissues and organs, and that is what we will gently explore together next. A single cell, existing entirely on its own, is a quiet marvel of nature. We have seen how it breathes, how it builds, and how it divides to continue its solitary journey. But if life had stopped there, the world would be a very quiet place, filled only with microscopic, drifting spheres. The true beauty of biology, and the reason you and I are able to rest here and think about these things, lies in the profound power of cooperation. Imagine a person living entirely alone in a deep, remote forest, miles away from any other human being. To simply survive, they must be a master of everything. They must chop their own wood, purify their own water, grow and hunt all of their own food, and build their own shelter. It is a life of constant, demanding effort, where every single day is consumed by the basic tasks of staying alive. There is very little time or energy left for anything else. But imagine what happens when a second person moves into the forest, and then a third, and then 100. They form a small village. Instantly, the burden is lifted. They no longer have to do everything themselves. They can specialize. One person who is deeply patient can spend their days tending to the crops. Another person who loves the quiet geometry of wood and stone can spend their time building sturdy homes. Someone else can bake the bread. Because they share the work, the village can achieve things that a single person in the woods never could. They can build a library, compose music, and rest. Your body is exactly like this bustling, specialized city. You are made of trillions of individual cells that long ago made the silent agreement to stop drifting alone and stay together. But this raises a beautiful mystery. We know from our time looking at cellular division that every single cell in your body contains the exact same master blueprint in its nucleus. The DNA in a cell on the tip of your nose is identical to the DNA in a cell deep within your liver. So, if they all hold the exact same library of instructions, how do they know to take on completely different jobs? To understand this, imagine being handed the master script for a massive, sprawling stage play, a play with thousands of different characters. The script contains every single word spoken by every single person. If you are cast in the role of the baker, you don't read the entire play aloud on stage. You gently flip through the heavy pages, find the specific scenes that feature the baker, and you highlight only those lines. You ignore the lines of the king, the soldier, and the sailor. You only read what applies to you. Your cells do the exact same thing. Even though every cell holds the complete, unbroken manual for building a human being, they only open the chapters that apply to their specific profession. A cell in your eye ignores the instructions for building bone, and a cell in your heart keeps the chapter on digesting food tightly closed. This quiet, deliberate choice to read only a fraction of their own potential is what allows a cell to specialize. When millions of these highly specialized cells, all reading the same chapter, gather together and interlock, they form what we call a tissue. You can picture a tissue as a vast, living fabric. Just as a heavy wool blanket feels entirely different from a sheet of fine, cool silk, the different tissues in your body have entirely unique textures and purposes. Imagine a piece of fine, deeply protective weather stripping, seamlessly sealing the windows of a house, or a layer of smooth, waterproof paint on a hull. This is your epithelial tissue. It is made of cells packed tightly edge to edge, forming the smooth sheets that cover your skin and gently line the hollow spaces inside you, like your throat and your stomach. Their job is to be the quiet guardians, the walls that hold the outside world at bay. Deep beneath those walls, you will find a different kind of fabric. Picture thick, flexible cables made of braided rubber bands, designed to stretch and pull with immense, sustained power. This is your muscle tissue. These cells have dedicated their entire existence to the art of movement, working together in perfect, sweeping rhythms to allow you to walk, to breathe, and to shift comfortably beneath your blankets. And holding all of this together is a vast, invisible scaffolding known as connective tissue. If the epithelial tissue is the wallpaper and the muscle is the engine, the connective tissue is the mortar between the bricks, the wooden beams in the walls, and the soft insulation in the attic. It is the quiet, sturdy support system that weaves through every part of you, binding the city together and ensuring that everything remains exactly where it belongs. But a pile of raw building materials, no matter how beautifully organized, is not a functioning home. True complexity arises when these different fabrics are carefully layered and woven together to build a machine. In biology, when different types of tissues unite to perform a specific, larger task, they form an organ. Consider the stomach, resting quietly just beneath your ribs. It is not just one thing, it is a profound collaboration. The outer layer is wrapped in a smooth, protective tissue holding it in place. Beneath that lies a thick, powerful layer of muscle tissue, patiently waiting to gently churn and mix your food. Deep on the inside, there is a specialized lining of protective tissue, carefully secreting fluids while simultaneously shielding the stomach walls from its own chemistry. And weaving through all of these layers is a delicate web of nerve tissue, the electrical wiring that tells the muscle when to squeeze and when to relax. None of these tissues could digest a meal on their own. The muscle would simply squeeze empty space, and the inner lining would have nothing to protect. But together, resting in perfect harmony, they become an organ capable of dismantling the food you eat and drawing life from the world. Your entire body is a sweeping landscape of these magnificent, cooperative organs. Your liver, your lungs, your skin, and your eyes are all vast, specialized factories working seamlessly alongside one another. They do not compete. They simply perform their incredibly complex tasks in the dark, asking for nothing but a steady supply of energy. It is a deeply peaceful thought to hold as you rest. You do not have to consciously manage any of this. You do not have to tell your stomach to digest, or your skin to heal, or your tissues to hold their shape. Trillions of lives, trillions of silent, beating engines, are all beautifully aligned for the singular purpose of maintaining the world that is you. But for a society this sprawling to actually survive, the distant outposts must be able to share their resources. The oxygen drawn in by the soft tissues of the lungs must somehow find its way all the way down to the muscles in your furthest toes. The nutrients gently processed by the stomach must be delivered to the intricate, electrical tissues of the brain. A grand society cannot function in isolation. It requires a vast, moving highway system to connect the quietest corners of the empire. And for a grand society to function, it needs a way to transport goods and messages across vast distances. That leads us gently into the moving rivers of your body. We ended our last moment together, marveling at the vast, specialized society of your tissues and organs. We imagined the body as a sprawling, brilliant city, where trillions of cells have agreed to share the space and the work of living. But a society of this magnificent scale cannot survive in isolation. If a muscle cell resting deep in your ankle is working hard to help you walk, it needs a continuous supply of fresh energy. At the same time, the quiet cells lining your stomach have gathered the nutrients from your dinner and need a way to distribute them to the rest of the empire. For a grand society to function, it needs a flawless, unbroken system of transportation. It needs a way to move vital goods, send urgent messages, and clear away the exhaust across the vast distances of your body. This brings us gently to the moving rivers within you. This is the story of your circulatory system. At the very center of this extraordinary network, resting safely beneath the protective cage of your ribs, sits the tireless engine of your life. This is your heart. We often speak of the heart in poetry and song, but its physical reality is even more beautiful than the metaphors. It is a dense, deeply powerful muscular pump, about the size of your softly closed fist. Unlike the muscles in your arms or your legs, which eventually need to rest after a long day of walking or lifting, the muscle of your heart is entirely unique. It never tires. It never asks for a break. From the quiet weeks before you were even born until this very moment as you rest here, it has been beating in a steady, unbroken rhythm, asking for nothing but your quiet existence. If you were to place your hand over your chest right now, or feel the gentle flutter at your wrist, you would sense that rhythm. But what you are actually feeling is not the muscle itself squeezing. The soft, rhythmic thud of your heartbeat is the sound of tiny, perfect doors closing. The heart is divided into quiet chambers. When the blood returns from its long journey around the body, it pools gracefully in the upper waiting rooms of the heart. Then, with a soft electrical spark, the heart squeezes, pushing the fluid down through delicate, one-way valves into the deep, powerful lower chambers. Once the blood is safely inside, those valves gently snap shut to prevent anything from flowing backward. That quiet, reassuring sound, the lub-dub you have known your entire life, is simply the sound of those living doors closing securely, sealing the chamber before the heart flexes its immense strength to push the blood out into the world again. When the heart pushes that fresh, bright red fluid outward, it enters a vast, branching highway system. These are your arteries. You can picture them as incredibly strong, flexible rivers. When the blood first leaves the heart, it enters a massive central artery, a vessel as thick as a garden hose, designed to handle the immense pressure of the heart's powerful squeeze. That pressure rippling outward through the fluid is what you feel as your pulse. But this great river cannot simply flood the body. It must be carefully managed. And so, the central artery begins to branch. It splits into 2 smaller rivers, which then branch into 4, and then into 8, spreading out in a beautiful, sprawling canopy that looks remarkably like the roots of an ancient tree. As the rivers travel further from the heart down your arms, deep into your abdomen, and stretching down toward your feet, they become smaller, quieter, and more gentle. The high-pressure roar of the central highway softly fades into the steady flow of a quiet country road. Eventually, these branching pathways become incredibly narrow. They become the capillaries. These are the tiniest creeks in your body, and they are so magnificently thin that their walls are made of just a single, flat layer of cells. They are so narrow that the blood cannot rush through them. It must slow way down. The tiny, floating delivery trucks of your blood, the red blood cells, must line up and move through these delicate creeks in a single, orderly file. This dramatic slowing of the pace is not an accident. It is the entire purpose of the journey, because it is here, in the quiet, narrow creeks, that the actual work of the delivery system takes place. Let us pause to admire the red blood cell itself. It is a masterpiece of biological dedication. To make as much room as possible for its vital cargo, the red blood cell does something profound as it matures. It ejects its own nucleus. It gives up its own master blueprint, sacrificing its ability to divide or rebuild itself, purely so it can carry more oxygen for the rest of the body. It is shaped like a soft, flexible disc, a tiny cushion designed to slip smoothly through the narrowest passages without ever getting stuck. As these dedicated, solitary couriers glide slowly through the capillary creeks, they pass intimately close to the waiting cells of your tissues. Because the walls of the creek are so beautifully thin, a silent, effortless exchange occurs. The fresh oxygen and the simple sugars from your food slip quietly across the border, drifting out of the blood and into the waiting arms of the hungry cells. But a true delivery system does not just drop off supplies, it must also collect the empty boxes. As the cells burn that energy in their tiny mitochondrial engines, they create waste, primarily carbon dioxide. While the fresh oxygen is slipping into the cells, this carbon dioxide exhaust is gently slipping back across the same thin border, safely boarding the red blood cells for the journey away from the neighborhood. Once the delivery is complete and the exhaust is loaded, the journey back home begins. The tiny creeks begin to merge together, forming slightly larger streams, which then flow together to form wide, quiet rivers. These are your veins. The journey through the veins is entirely different from the journey through the arteries. There is no longer any high pressure. The powerful push of the heart has long since faded away into the delicate capillary beds. The blood in your veins is moving slowly, under very low pressure, and often it has to travel straight up against the heavy pull of gravity to get back to your chest. To accomplish this peaceful return journey, your veins rely on the gentle movements of your life. Every time you take a slow breath, every time you shift your weight in your bed, or take a simple walk around your neighborhood, your skeletal muscles softly squeeze against the outside of your veins. This gentle pressure nudges the blood upward. And to ensure the fluid doesn't simply slide backward when you stop moving, the insides of your veins are lined with tiny, delicate pockets that act as soft safety valves. They catch the resting blood, holding it securely like water in a quiet lock, waiting for your next breath or your next movement to push it a little closer to home. It is a flawless, deeply elegant loop, running continuously day and night. The brilliant, quiet factories of your body are constantly supplied, the streets are kept perfectly clean, and the solitary, dedicated red blood cells travel hundreds of miles over their short lifetimes, asking for nothing but to serve the whole. And with that massive, unbroken delivery system softly mapped out in our minds, we are naturally led to a lingering question. When those trillions of tiny delivery trucks finally return to the center of the chest, heavy with the carbon dioxide exhaust of the city, they must empty their cargo. And they must find a place to gather the fresh, vital oxygen for their next journey out into the dark. Where do they go to perform this essential, silent exchange? That is what we will gently explore next. We ended our last moment asking a vital question. Trillions of tiny delivery trucks, your red blood cells, are constantly returning to the center of your chest, heavy with the carbon dioxide exhaust of the body's hidden cities. They have traveled through the slow, quiet rivers of your veins, nudged upward by the gentle movements of your life, to arrive back at the heart. But the heart is just a mechanical pump. It cannot clean the blood, and it cannot restock the oxygen. To perform this essential, silent exchange, the heart must send this exhausted blood on one short, beautiful journey right next door. It sends it to your lungs. This brings us to the process of breathing, the quiet rhythm that anchors your entire existence. Right now, as you rest, you are doing it without thinking. You take a slow breath in, gently pulling from the world. You let a slow breath out, gently giving back to it. It is so constant, so familiar, that we rarely stop to consider what a profound mechanical and chemical miracle is taking place deep within our chests. To understand this exchange, let us imagine the journey from the perspective of the air itself. The space around you right now, the air filling your room, is not empty. It is a rich, invisible ocean made mostly of nitrogen, with a vital thread of oxygen woven throughout. When your chest softly expands, you create a tiny drop in pressure, and this invisible ocean effortlessly flows into you. As the air enters your nose, it is immediately welcomed and prepared. Your body does not want cold, dry, unfiltered air reaching its most delicate internal spaces. So, the passages of your nose act like a beautifully designed entryway to a grand home. The air is gently warmed to match the perfect internal temperature of your body. It is moistened, gathering water vapor so it will not dry out your fragile tissues, and it is swept clean by microscopic, sweeping hairs that catch any passing dust. By the time the air has traveled just a few inches down into the back of your throat, it has been perfectly conditioned and is ready to enter the depths. From there, the air descends into the central tube of your chest. You might imagine this as a strong, flexible pipe, kept open by soft rings of cartilage, ensuring the pathway is always clear, whether you are running a marathon or sleeping soundly. But this central tube cannot simply empty into a large, hollow cave. If your lungs were just two empty balloons, there would not be nearly enough surface area to catch the massive amount of oxygen your sprawling society of cells demands. Nature solves this problem with one of its favorite and most beautiful designs, branching. Imagine a grand, ancient oak tree resting in a quiet winter field, its leaves completely fallen. You see the massive, thick trunk rising from the earth. That is the central tube in your chest. Now, watch as that central trunk splits into two massive branches, one reaching into the left side of your chest and one reaching into the right. These are the main pathways entering your two lungs. But the branching has only just begun. Each of those large branches divides into smaller branches, and those divide into even smaller branches, and then into tiny twigs, splitting again and again, deeper and deeper into the soft, spongy tissue of your chest. The pathways become narrower, quieter, and more intricate, spreading out until they form a magnificent, upside-down canopy inside you. If you follow the air all the way down, past the trunk, past the large branches, and through the tiniest, microscopic twigs, you finally reach the end of the journey. You arrive at the leaves of this hidden tree. In the lungs, these leaves are called alveoli. They are microscopic, incredibly delicate air sacs. Imagine millions of soft, tiny balloons clustered closely together, resembling microscopic bunches of grapes. The walls of these tiny balloons are impossibly thin, so thin that they are virtually transparent. It is almost impossible to comprehend the scale of this design without stepping back, but let us try to picture it. If you were to somehow take all of those millions of microscopic balloons inside your chest, gently open them up, and lay their thin tissues out flat on the ground, they would not just cover a small dining table. They would spread out to cover the entire surface of a tennis court. You have a tennis court's worth of delicate, shimmering surface area folded quietly and compactly inside your chest, waiting to catch the air. And it is exactly here, at the very edge of these delicate balloons, that the magic happens. Wrapped around the outside of every single one of these microscopic balloons is a fine, tight net of those tiny capillary creeks we explored earlier. This is where the exhausted, returning red blood cells have been sent. They line up in the narrow creeks, pressing themselves as close as they can to the incredibly thin walls of the air sacs. On one side of this microscopically thin wall is the fresh, conditioned air you just breathed in, rich and heavy with oxygen. On the other side is the dark, returning blood, heavy with the carbon dioxide exhaust from the body's deep cellular factories. What happens next is an act of pure, effortless balance. There is no struggling. The body does not have to spend a single drop of its own energy to make the exchange. It relies on a simple, universal truth of nature. Things naturally want to move from where it is crowded to where there is open space. Because there is so much oxygen in the fresh air and so little in the returning blood, the oxygen simply slips right through the thin wall, drifting across the border and settling comfortably into the waiting red blood cells. At the exact same instant, the carbon dioxide, which is highly crowded in the blood, smoothly slips across the border in the opposite direction, moving out of the blood and into the empty space of the soft balloon. It happens in a fraction of a heartbeat, a silent, perfect swap in the dark. The red blood cells, now bright and rich with fresh oxygen, are gently swept away. They travel back to the strong, waiting chambers of the heart, ready to be pushed out to the furthest reaches of the empire once again. They leave their heavy exhaust behind, trapped softly in the little balloons. Then, the muscles of your chest gently relax. The space inside you shrinks just a little, and all of those millions of tiny balloons softly deflate. The carbon dioxide is pushed backward, up through the tiny twigs, into the larger branches, up the strong central trunk, and smoothly out into the world. When you breathe out, you are not just pushing air. You are physically releasing a piece of your own internal chemistry. The carbon that once built the food you ate, that was burned by the microscopic engines of your cells to give you the energy to walk and talk, is now floating away from you, returning to the vast atmosphere of the earth. The trees outside your window will soon catch that very same carbon on the breeze, pulling it into their own leaves to build wood and roots. You are in a constant, unbroken conversation with the world. You take a breath in, pulling from the atmosphere, drawing the invisible resources of the earth deep into your own chest to fuel your life. You let a breath out, offering the physical exhaust of your existence back to the world, providing the exact material the plants and trees need to survive. It is a beautiful, deeply comforting loop. You do not have to earn it, and you do not have to manage it. Your body simply asks for what it needs, and the world provides it. Let's set that quiet, rhythmic breath down now, fully formed, and let our attention drift. We have seen how we draw the invisible spark of the air into our blood. But life requires more than just oxygen. To maintain the grand, physical architecture of your body, we must draw tangible, heavy substance from the world around us. We must gather the blocks to build the city. And that leads us to the warm, patient process of breakdown and rebuilding. Just as we pull the invisible spark of oxygen from the air around us, we must also draw tangible, physical substance from the world. We cannot build a physical body out of thin air. To grow, to heal, and to gently replace the millions of cells that quietly finish their journey each day, we need raw materials. We need the fundamental building blocks of life. And we gather these blocks through the warm, patient process of digestion. To understand what digestion truly is, you have to let go of the idea of food as just a meal on a plate. Think of it, instead, as borrowed architecture. Imagine you have just bought a beautiful piece of land, and you want to build a winding brick pathway through a garden. On this land, there happens to be an old, crumbling brick wall. You wouldn't try to shove the entire wall into the ground to make your path. You would gently and deliberately take the wall apart. You would chip away the old mortar, clean off each individual brick, and sort them into neat, organized piles. Only then would you have the raw materials to build whatever new, beautiful shape you desired. Your digestive system is doing exactly this every single day. The food you eat, whether it is a crisp apple, a handful of almonds, or a warm piece of bread, is the old brick wall. It is a structure built by another living thing, holding its own shape and serving its own purpose. Your body cannot use an apple to build human muscle or human skin. It must carefully dismantle the apple, piece by tiny piece, breaking it down into its most basic chemical foundations. Once it has stripped away the old architecture, it absorbs those clean, sorted building blocks and uses them to patiently rebuild you. This long, winding journey of dismantling begins the moment you take a bite. Your teeth perform the first heavy work of breaking the structure apart, while your saliva begins a much quieter, invisible task. Saliva is not simply water. It is filled with those tiny, folded protein machines we explored earlier, the enzymes. Think of these enzymes as millions of microscopic pairs of scissors, specially shaped to find complex starches and carefully snip them into smaller, sweeter pieces. Even before you swallow, the chemical unweaving of your food has already begun. When you finally do swallow, you hand control over to a deeply trusting, automatic process. The food slips into a long, muscular tube that leads down into the dark of your chest. This tube does not simply rely on gravity to do its job. If you were resting entirely upside down, the water you drank would still reach its destination. That is because the walls of this tube are lined with strong, smooth muscles that contract in a beautiful, rolling wave, gently and firmly pushing the contents downward. It is a slow, rhythmic squeeze, much like smoothly pressing the last bit of toothpaste from the bottom of a tube up to the top. This rhythmic wave delivers the food into the stomach, which rests safely just beneath your ribs. It is common to picture the stomach as a kind of aggressive, mechanical blender, but it is actually much more elegant than that. It is a thick, muscular pouch, acting as a quiet, warm, chemical bath. The walls of the stomach secrete a powerful, specialized acid. In the outside world, an acid this strong could be quite dangerous. But your stomach is lined with a constant, renewing layer of thick fluid that perfectly protects it from its own chemistry. The true purpose of this warm acid bath is to deal with the complex proteins in your food. We talked earlier about how proteins are long chains of amino acids folded up into intricate, three-dimensional shapes. When those complex, tightly folded shapes hit the warm acid of the stomach, they begin to relax. They slowly unfold, losing their rigid structure and stretching out into long, loose strings. It is remarkably similar to watching a tightly wound ball of yarn slowly unravel. Once the strings are stretched out in the open, a new set of microscopic scissors steps in. clipping those long threads into smaller, manageable fragments. After a few hours of gentle churning, the dismantled food is carefully released, just a little bit at a time, into the most magnificent and complex stretch of the entire journey, the small intestine. This is a remarkably long, winding, and narrow tube, coiled neatly in your lower abdomen. If the stomach was the heavy dismantling room, the small intestine is the grand sorting and processing facility. As the food enters this winding corridor, it is greeted by a rush of soothing fluids from your internal organs. These fluids act perfectly to neutralize the harsh stomach acid, bringing the environment back to a calm, gentle balance. They also carry the final, most precise set of biological tools. These tools patiently break down the remaining fragments, separating the complex fats into simple, smooth, fatty acids, the final starches into pure, clear sugars, and those short threads of protein into individual, solitary amino acids. The old architecture is completely gone. What remains is a soft, flowing river of pure, sorted building blocks. The only task left is to pull them inside. To do this, the walls of the small intestine are covered in millions of microscopic, finger-like projections. If you could gently run your hand over them, they would feel softer and denser than the finest velvet. This incredibly dense velvet lining dramatically increases the surface area of the intestine, ensuring that, as the fluid moves through, not a single usable molecule is wasted. Hidden inside every single one of those tiny velvet fingers is a microscopic bed of blood vessels. As the river of nutrients flows softly by, the simple sugars, the basic fats, and the individual amino acids slip quietly across the delicate barrier. They drift out of the digestive tract and directly into your bloodstream. They are caught by the sweeping current of your circulatory system and carried away into the dark, delivered to every single cell in your living empire to rebuild your tissues, fuel your thoughts, and keep your internal fires burning. It is a sprawling, multi-stage operation involving powerful muscles, perfectly balanced chemicals, and millions of microscopic machines, all working together without a single conscious thought from you. But how does the body coordinate all of this dismantling, rebuilding, pumping, and breathing? How does the stomach know exactly when to produce its acid, or the heart know precisely how fast to push the blood to collect the new nutrients? To manage a society of this magnificent scale, you need more than just building blocks and energy. You need a way for the distant outposts to talk to one another. You need a master communication network. That is what we will gently explore next, as we turn our attention to the delicate, crackling web that ties everything together. We ended our last moment together, reflecting on a magnificent problem of scale. We have seen how the stomach carefully dismantles the food you eat, how the lungs draw invisible oxygen from the air, and how the beating heart pushes these vital resources through thousands of miles of branching rivers. But a society of this immense size, with trillions of individual cells all working at exactly the same time, cannot simply operate on its own without guidance. If the muscles of your legs decide to take a walk, the heart must instantly know to beat a little faster, and the lungs must know to pull in more air. To manage a sprawling, complex society perfectly, you need more than just building blocks and energy. You need a master communication network. You need a way for the furthest, quietest corners of the empire to instantly talk to the center, and for the center to reply. This brings us gently to the delicate, crackling web that ties your entire existence together, the nervous system. At the very top of this network, resting quietly in the absolute dark of your skull, is the grand command hub of your body. This is your brain. It is a profoundly beautiful paradox. Your brain has no eyes, yet it creates all the light and color you have ever seen. It has no ears, yet it processes the complex, sweeping melodies of your favorite music. It sits in a silent, perfectly dark, heavily protected vault, relying entirely on the messages sent to it from the outside world. It is the central processor, the quiet observer, and the keeper of every memory you have ever made. But the brain cannot reach out and touch the world on its own. To communicate with the distant outposts of your body, It relies on a massive, heavy cable of wiring that drops down from its base. This is your spinal cord. You can picture it as the main fiber optic trunk line of a vast internet network. Because the messages traveling up and down this main cable are so unbelievably precious, the body protects it with a beautifully engineered suit of armor. Your spine is a column of thick, interlocking bones, with the delicate cable running safely down the hollow center, guarded against the shocks and movements of your everyday life. From this thick central cable, the network begins to branch. Just as the massive central arteries split into smaller and smaller rivers, the nerves branch out from the spaces between your backbones. They reach outward, spreading across your chest, winding down your arms to the very tips of your fingers, and stretching deep into your legs and toes. They weave into the walls of your stomach and wrap gently around the chambers of your heart. There is virtually no place in your body that is not touched by this fine, delicate web. To understand how a message actually travels across this vast distance, we must zoom in once again and look at the specialized cells that make up this network. They are called neurons. If you could see a neuron, you would not see a simple, round drop of fluid. Instead, a neuron looks remarkably like an ancient, deeply rooted tree. It has a central body, but reaching out from that center is a sprawling canopy of tiny, delicate branches designed simply to listen. Stretching out in the other direction is a single, incredibly long trunk, sometimes up to 3 feet long, designed to carry a message away. These long trunks bundle together like the wires inside a heavy electrical cord, forming the nerves that travel through your body. When a neuron wants to communicate, it does not rely on the slow, drifting currents of the bloodstream. It uses something much faster. It uses a tiny, soft spark of electricity. Imagine you are resting exactly as you are right now, and you decide you want to wiggle your toe. A tiny, quiet spark of intention begins in the dark vault of your brain. That spark ripples outward, traveling down the main fiber optic cable of your spine. It finds the exact exit pathway for your leg, speeds down the long trunk of the neuron, and arrives at the muscles of your toe, telling them to contract. This entire journey, spanning the entire length of your body, happens in a fraction of a single second. It is a biological internet, alive with a quiet, crackling energy. But there is a beautiful, deeply elegant twist to how these neurons connect. If you trace that electrical spark down the long trunk of the tree, you would expect it to simply touch the next cell and pass the electricity along, like 2 copper wires twisted together. But the neurons do not actually touch. At the very end of the line, right before the neuron meets the next cell, there is a microscopic gap. The electrical spark cannot cross this empty space. It is as if a speeding train has suddenly reached the edge of a wide, unbridged river. When the electrical spark reaches the edge of this gap, it stops. The sudden halt forces the edge of the neuron to release thousands of tiny, specialized chemicals into the water. You can picture these chemicals as a fleet of silent, microscopic ferries. They drift across the incredibly narrow river, carrying the message with them. When they reach the far shore, they dock gently into waiting receptors, the biological doorbells we explored earlier. As soon as the ferries dock, a brand new electrical spark is instantly ignited on the other side, and the message continues on its way. This happens billions of times a second inside you. Every time you smell fresh rain, every time you recall the face of a friend, every time you feel the soft, comforting pressure of the blankets resting against your skin right now. It is the result of these tiny electrical sparks racing down the branches and the silent fleets of chemical ferries crossing the gaps. And yet, perhaps the most wonderful part of this vast electrical web is what it does without you ever having to ask. While a portion of your nervous system is dedicated to your conscious thoughts and movements, a massive hidden portion is entirely automatic. Think of the background operating system on your phone, quietly managing the battery, updating the time, and searching for a signal while you simply look at the screen. Your autonomic nervous system is the quiet caretaker in the background. As you drift closer to sleep, you do not have to calculate how much acid your stomach needs to digest your dinner. You do not have to consciously measure the carbon dioxide in your blood and tell your lungs to take the next breath. You do not have to manually set the rhythm of your heart. The crackling web of the nervous system measures, calculates, and coordinates all of it in the dark, flawlessly adjusting the dials of your internal world so that your conscious mind is free to rest, to imagine, and to dream. It is an incredibly sensitive, beautifully balanced system. It is the very essence of how you experience your life. A moment ago, we ended with the idea of this sensitive, feeling web running quietly through every corner of your physical being. Let us pick up that thread right where we left it. Because your body is so rich with resources, so comfortably warm, and so beautifully organized, it is an incredibly inviting environment. And occasionally, the outside world attempts to cross your borders. How does the body protect such a delicate, intricate system from unwelcome visitors? That is what we will gently explore next, as we meet the quiet defenders of your internal city. We left our journey reflecting on the magnificent, crackling web of the nervous system, quietly managing the vast city of your body. Because this internal city is so beautifully organized, so constantly supplied with fresh oxygen and warm, rich nutrients, it is an incredibly inviting environment. It is a microscopic utopia. It is perfectly climate-controlled, bathed in soft, fluid rivers, and sheltered from the harsh elements of the outside world. And naturally, such a perfect sanctuary occasionally attracts unwelcome visitors. As you move through your daily life, opening doors, sharing meals, taking deep breaths in crowded rooms, tiny, microscopic entities like bacteria and viruses are constantly brushing against you, looking for a warm place to rest and multiply. To protect your peaceful, functioning society of cells from these visitors, your body possesses a defense network of breathtaking sophistication. We call this the immune system. It is common to hear the immune system described with words of conflict and war as a violent battlefield of soldiers and invaders. But as you lie here, resting peacefully, I want you to set aside that chaotic imagery. Inside your body, there is no noise, there is no panic. Instead, you can imagine your immune system as a vast, incredibly quiet, and deeply attentive neighborhood watch. The first line of this quiet defense is simply the grand wall of your skin, the smooth, interlocking epithelial tissue we explored earlier. It acts as a flawless, waterproof boundary that keeps almost all wandering strangers out. Even the openings of your body, like your eyes and your mouth, are guarded by gentle, washing fluids, tears, and saliva that contain soft enzymes designed to quietly dismantle any stray bacteria before they can even settle. But occasionally, a visitor slips past these outer walls. Perhaps you get a small paper cut, or a tiny virus manages to drift down the winding branches of your lungs. When a stranger enters the internal city, the neighborhood watch calmly steps in. The patrollers of this watch are your white blood cells. If the red blood cells we met earlier are the dedicated delivery trucks carrying oxygen, the white blood cells are the quiet, roaming guardians. They drift smoothly alongside the red blood cells in the slow-moving rivers of your veins and arteries. But unlike the red blood cells, which are confined to the water, the white blood cells have a remarkable ability. When they sense that they are needed, they can gently squeeze themselves right through the thin walls of the capillary creeks and slip out into the surrounding tissues, walking silently among the cells of your body. As these guardians patrol the neighborhood, they are constantly performing a delicate, microscopic handshake. Every single cell that truly belongs to your body carries a tiny, specific protein shape on its outer surface. You can think of it as a biological name tag, or a specialized passport. As the white blood cells drift through the tissues, they reach out and gently touch the surface of every cell they pass. They feel for that familiar name tag. They are silently asking, "Do you belong here?" And the cell, presenting its unique protein shape, silently answers, "Yes, I am a part of this whole." The patroller recognizes the shape, releases its gentle grip, and smoothly moves on. But a wandering bacterium or a drifting virus does not have this passport. It carries a completely different shape on its surface. a texture that is entirely foreign to the quiet harmony of your body. When a patrolling white blood cell reaches out and touches one of these strangers, it instantly realizes that the shape is wrong. There is no alarm bell. There is no sudden chaos. Instead, the white blood cell responds with a coordinated chemical embrace. Some of these guardian cells are designed to act like gentle sweepers. When they encounter a wandering bacterium, they simply open up and envelop it, pulling the stranger entirely inside themselves. Once the visitor is safely contained within the sweeping cell, it is quietly dismantled using those same warm, digestive enzymes we saw in the stomach, breaking the stranger down into harmless, basic molecules that can be washed away. This sweeping process is incredibly efficient, handling thousands of tiny intrusions every single day without you ever feeling a thing. But the true brilliance of the immune system, the part that elevates it from a simple neighborhood watch to a profound, lifelong guardian, lies in its ability to remember. When a new, highly unfamiliar visitor enters the body, sweeping it away is not enough. The immune system wants to ensure that this specific stranger can never cause trouble again. So, when the white blood cells encounter a new virus, they perform an extraordinary act of biological photography. They carefully examine the unique, foreign shape on the surface of the intruder, and they carry that specific shape back to the specialized, quiet corners of your immune system, like the lymph nodes resting softly in your neck and under your arms. In these quiet halls, a different set of highly specialized white blood cells goes to work. They study the shape of the intruder, and they begin to craft a perfect, custom-made lock to fit the stranger's unique key. These custom creations are called antibodies. You can picture them as tiny, beautifully folded, Y-shaped proteins. They are designed with one single, exclusive purpose: to perfectly latch onto that exact stranger and no one else. The immune system quietly manufactures millions of these tiny, custom keys and releases them into the flowing rivers of your blood. They drift through your body like microscopic, floating flags. If they ever bump into that specific intruder, they snap perfectly into place, attaching themselves to the visitor's surface. This serves two beautiful purposes. First, it completely neutralizes the intruder, wrapping it up so it cannot enter your cells or cause any harm. Second, it acts as a brightly colored tag, softly signaling to the sweeping cells that this specific entity needs to be escorted out immediately. Once the visitor is completely cleared from the city, the body stops manufacturing the massive fleet of custom keys. But it never forgets. A small number of specialized memory cells, carrying the exact blueprint for that specific antibody, retreat into the quietest spaces of your body, sometimes resting deep within the marrow of your bones. They will live there for decades. They will wait silently for years, holding onto the memory of that exact shape. If that same visitor ever tries to cross your borders again, even 10, 20, or 40 years later, the immune system does not have to spend time examining it or learning how to fight it. The memory cells instantly recognize the familiar face, awaken from their long sleep, and flood the rivers with the perfect custom keys before the intruder has even unpacked its bags. You will not even feel a tickle in your throat. You will simply go about your day, completely unaware that a magnificent, invisible defense just flawlessly protected your existence. This is the gift of immunity. It is a sprawling, deeply intelligent library of your life's encounters, allowing you to walk freely through a crowded world. Your body learns from everything it touches, quietly adapting, remembering, and preparing, ensuring that the sanctuary remains whole. But this incredibly sophisticated ability to remember and to pass information along is not just a feature of your immune system, it is the defining feature of life itself. Before we rest here, let me whisper where we're headed next, looking past the life of a single cell and past the borders of a single body. We are going to explore how life remembers itself, not just over years, but across centuries and generations. We will gently unspool the deepest threads of the grand library as we turn our minds to the beautiful story of inheritance and the long, unbroken chain of you. We left our journey reflecting on the immune system, marveling at its ability to remember a passing encounter for the entire span of your life. It is a brilliant, quiet memory that protects your individual existence. But there is another kind of memory resting inside you. It is a memory far older and far deeper than the events of your own life. When we look past the daily operations of a single cell and past the borders of a single body, we discover how life remembers itself not just over years, but across centuries and generations. We gently unspool the deepest threads of the grand library, turning our minds to the beautiful story of inheritance and the long, unbroken chain of you. Let us return to the very center of the cell, to the quiet, dark vault of the nucleus where the master blueprint is kept. We have talked about how this long, twisting thread of DNA holds the instructions for building your physical form. We have watched the cell carefully read those instructions to build proteins, and we have watched it flawlessly duplicate the entire library right before it divides. But we have not yet asked the most profound question of all. Where did your specific blueprint come from? It was not invented out of thin air on the day you began. It was handed to you. The story of inheritance is beautifully similar to the shuffling of a vast, magnificent deck of cards. Imagine a deck not of 52 cards, but of tens of thousands of unique instructions. When it is time for life to be passed down and a new generation to begin, the body does something incredibly humble and deliberate. It does not pass on the entire library. If it did, the new life would simply be an exact, identical copy, and the world would be a very static, unchanging place. Instead, specialized cells in the body prepare for the future by intentionally splitting the deck in half. In a beautiful, quiet variation of cell division, the twisting ladders of DNA are carefully unzipped and separated. But instead of rebuilding the missing sides immediately, these special cells, the cells that will eventually create a new life pause, they hold on to just one half of the ladder. They pack away just half of the master instructions, leaving the other half behind. It is a biological offering, an incomplete puzzle waiting to be finished. When a new life is conceived, it is the merging of two of these incomplete puzzles. One half of the grand library is offered by one parent, and the other half is offered by the other. When these two distinct halves meet in the warm, dark quiet of the beginning, they reach out and gently zip together. They interlock perfectly, forming a brand new, complete, and fully restored double helix. But because the deck was so vast, and because it was shuffled before it was split, the combination that forms in that moment is entirely unprecedented. When those two halves merge, they create a completely unique sequence of instructions, a specific arrangement of the chemical alphabet that has never existed before in the entire history of the world, and will never exist again. You are not a copy. You are a wholly unique, unrepeatable event in the universe, woven together from the threads of two different histories. Yet, this brings up a fascinating dilemma. If you receive a complete set of instructions from one parent and another complete set of instructions from the other parent, you essentially have two slightly different instruction manuals for how to build a human being. You have two chapters on how to shape an ear, two chapters on how to color an eye, and two chapters on how to build the delicate architecture of your hands. How does the body know which set of instructions to read? Imagine two brilliant architects handing you a blueprint for the front door of your new home. One architect has drawn a heavy, dark wooden door. The other has drawn a door painted bright blue. You cannot build both doors in the exact same frame. You must make a choice. In your DNA, these varying instructions act in much the same way. Sometimes, one instruction is simply louder than the other. It acts like a dominant, carrying voice in a quiet room. If the instruction for dark hair is loud, and the instruction for light hair is soft, the body will listen to the louder voice, and your hair will be dark. The softer instruction is not destroyed or lost. It is simply kept quiet, held safely in the library, where you might one day pass it on to the next generation. At other times, the two instructions are perfectly equal in their volume, and the body beautifully compromises. It reads both blueprints at the same time, blending the colors or shapes together to create something softly in between. This intricate, silent negotiation between the overlapping chapters of your parents' DNA is what paints the final, physical picture of who you are. You can see the results of this quiet negotiation in your own life. When you look in the mirror, or when you look at an old family photograph, you are witnessing the physical reality of inheritance. The shape of your eyes, the specific curve of your smile, or the deep, resting tone of your voice, these are not random traits. They are the physical echoes of people who lived long before you. You might carry the exact shape of your grandmother's hands, or the way a great-grandfather tilted his head when he listened. You have inherited pieces of a biological puzzle from generations of people you have never met, but who are nonetheless physically present in the way you walk, the way you breathe, and the way your cells gather energy in the dark. It is a profound thought to hold as you rest here. The twisting thread of information inside your cells has never been broken. It is a continuous, physical line. It was passed to you from your parents, who received it from theirs, stretching backward through your grandparents, your great-grandparents, and on into the deep, fading mists of history. Every single one of your ancestors, through winter storms, through vast ocean crossings, through times of quiet peace and years of unimaginable struggle, survived long enough to pass this fragile thread forward. They kept the library safe, and they handed it to the next caretaker. You are the current, living custodian of a very old, very resilient spark. You are tethered to the deep past, linked to the long story of humanity by the delicate, twisting ladders resting inside your cells right now. But because the deck of cards is shuffled every single time a new generation begins, the story is never completely stagnant. Every child is slightly different from their parents. Every new generation carries tiny, quiet variations in their physical form. While these changes might seem entirely invisible from one year to the next, what happens when we step back and look at those tiny variations over an incredibly long timeline? If we watch the unbroken thread of life, not over days or centuries, but over millions and millions of years, we see that the story is in constant motion. And with that deep connection to the past quietly in place, we're naturally led to ask how that story has shifted over vast oceans of time. We are led to the long, slow, and beautifully patient dance of change. That is what we will gently explore next. We ended our last moment looking at the beautiful, continuous thread of inheritance. We saw how the grand library of DNA is carefully shuffled and passed down, ensuring that every new life is an entirely unique, unrepeatable event. Over a few generations, this quiet shuffling creates the subtle, familiar differences we see in our own families: a slightly taller stature, a different shape to the jaw, or a new shade of hair. But we ended by asking a much larger question. What happens when we take that tiny, quiet variation and let it play out over vast oceans of time? When we zoom out and look at life not over days or years, but over millions and millions of years, we witness a beautiful, slow-moving dance called evolution. To truly understand this dance, we have to gently adjust our sense of time. As adults, we are used to measuring time in the span of a human life. We think in terms of weeks, of financial quarters, of the years it takes to carefully pay off a mortgage, or the decades it takes to watch a child grow into adulthood. To us, a century feels like an incredibly long, heavy amount of time. But in the story of biology, a century is not even a single blink of an eye. The Earth measures time in deep, sweeping epochs. Imagine standing at the base of a massive, jagged mountain range. To your eyes, those mountains are permanent, unmoving, and entirely still. But if you could view those mountains from the perspective of the Earth itself, speeding time up by millions of years, you would see that the mountains are actually deeply fluid. You would watch them push slowly upward from the ground like ripples on a quiet pond, only to be patiently worn back down to dust by the soft, persistent grace of the rain and the wind. Evolution requires this exact kind of vast, unimaginable canvas. It is not a process of sudden, dramatic transformations. It is the slow, patient accumulation of tiny, almost invisible changes, playing out over millions of generations. How does this change actually happen? It relies entirely on the world around it. The Earth, much like the life it holds, is never truly still. Over long stretches of time, the environment is constantly shifting. Lush, dense forests slowly dry out and turn into sweeping grasslands. Vast, warm oceans quietly recede, leaving behind dry valleys, while towering glaciers creep down from the poles to wrap the world in ice. As the world shifts, the creatures living within it must naturally adjust to their new reality. Because every new generation receives a slightly shuffled deck of genetic cards, no two animals or plants in a population are ever exactly alike. Within any group, there is always a gentle, natural variety. Imagine a sprawling, multi-generational family business that has been making heavy, insulated winter coats for a century. They live in a very cold, harsh climate, so the heavy coats are perfect and the business thrives. But very slowly, over the next few hundred years, the climate of their town begins to warm. It happens so softly that no single generation really notices the drastic shift. However, during the slightly warmer winters, the family members who happen to design slightly lighter jackets sell more than those holding onto the heaviest designs. Those lighter jackets become the new standard. Then, a few generations later, the descendants who try using breathable linen find even more success. Slowly, over centuries, without ever holding a grand meeting to completely change their entire company, the family naturally shifts from making heavy winter coats to making light, breezy summer shirts. They simply adapted to the immediate reality of the world they found themselves in. This is the quiet genius of natural selection. It is not a conscious decision, and it is not a panicked race toward a perfect finish line. It is simply the environment acting as a soft, continuous filter. If an animal happens to be born with a slightly thicker coat of fur just as the world begins to cool, it will naturally stay a little warmer. It will have a slightly easier time finding food, and it will be more likely to survive and pass that thick fur blueprint on to its children. Over countless generations, like water slowly and patiently smoothing the rough edges of a stone, that helpful trait becomes woven into the entire species. This slow dance of adaptation leaves physical echoes behind, and you carry some of these beautiful fading echoes inside your own body right now. Think about what happens when you step outside on a chilly morning without a jacket, or when you listen to a piece of music that moves you deeply. You get goosebumps. Tiny muscles at the base of your arm hairs contract, pulling the delicate hairs straight up. For us, this reaction does not accomplish very much, but it is a ghost from a very distant past. Millions of years ago, our deep ancestors were covered in a thick coat of fur. When they grew cold, those exact same tiny muscles would contract, puffing the fur up to trap a layer of warm air against the skin, insulating them perfectly against the chill. We no longer have the fur, but the quiet electrical wiring for the reflex remains, resting softly in the background of your nervous system. It is a biological antique, a reminder that we were not just dropped into this world fully formed, but that we grew out of it, slowly shaped by the cold winds and the changing landscapes of a much older Earth. We also carry other quiet reminders, like the wisdom teeth that often crowd the back of an adult jaw. They were perfectly suited for an ancient diet of tough, uncooked roots and wild plants, requiring immense chewing power. Today, they are largely unnecessary for the soft, cooked meals we enjoy. Yet they still gently push their way forward, honoring an old instruction manual. These fading marks are not flaws. They are the breathtaking proof that you belong to a continuous, unfolding story. Evolution teaches us that life is not rigid. It is deeply resilient, beautifully flexible, and intimately tied to the rocks, the water, and the air. Every species you see today, the birds resting in the trees, the moss growing on the damp stones, the deer stepping quietly through the woods, and the humans resting in their homes, is simply a snapshot in a moving picture. We are all perfectly, temporarily adapted to the world exactly as it is right now. And as the world continues to change, life will continue its slow, quiet dance, shifting its shape to embrace whatever comes next. Let's set that grand, sweeping timeline down now, fully formed. Let us leave the millions of years behind, and let our attention drift gently toward the present moment. We have looked at the deepest past, but what of the world we share today? How do all these beautifully adapted species, these vast collections of quiet cells, rely on one another to survive in the here and now? That is what we will softly turn to next, as we explore our shared resting place. We left our journey watching the slow, patient dance of evolution over millions of years, marveling at how life gently shifts its shape to embrace a changing world. But now, let us leave those vast oceans of deep time behind. Let us set down the heavy weight of history and gently bring our attention all the way back to the present moment. We have looked deeply inward, down to the microscopic architecture of your cells, and we have looked backward, deep into the mists of your ancestry. There is only one place left to go. We must zoom out as far as our minds will allow, looking past the walls of your room, past the borders of your town, and out into the quiet dark of space to see the world we share today. Imagine, for a moment, that you are drifting in the deep, absolute silence of space, looking back at the Earth. From that immense distance, you do not see cities or highways or the daily concerns of our busy human lives. You see a single, beautiful, glowing marble suspended in the dark, wrapped in swirling white clouds and deep blue oceans. If you look very closely at the edge of that marble, you will see a tiny, fragile halo of glowing atmosphere. It is unimaginably thin. If the Earth were the size of a common apple resting in the palm of your hand, the entire zone where life exists, the deepest trenches of the ocean, the highest peaks of the mountains, and the breathable air above would be no thicker than the delicate skin of that apple. This impossibly thin, shimmering layer is the biosphere. It is the shared resting place for every single thing we have spoken about tonight. Every dividing cell, every beating heart, every twisting thread of DNA, and every quiet breath is entirely contained within this soft, fragile skin. When we zoom out this far, a profound and beautiful truth reveals itself. The biosphere is not just a collection of separate animals and plants living near one another. It is a single, massive, intricately woven web of physical exchange. The boundaries we feel in our daily lives, the sense that where your skin ends, the rest of the world begins, are entirely an illusion. You are in a constant, unbroken physical dialogue with the Earth. Consider the water resting inside your body right now. It fills the clear, quiet fluid of your cells. It flows through the slow rivers of your veins, and it cools your skin. But this water is not permanently yours. It is simply on loan to you. You can think of it like a beautiful, well-worn book from a grand public library, passed from hand to hand over countless years. The water keeping you alive tonight has had an unimaginably long journey. It may have once evaporated from the warm, glassy surface of an ancient, tropical ocean. It may have been carried on high, rushing winds across entire continents, before falling as heavy, quiet snow on a jagged mountain peak. It may have melted over a century, filtering slowly down through dark, heavy layers of limestone and granite, resting in a deep underground aquifer before finally making its way to your glass today. And tomorrow, or the next day, it will gently leave you, evaporating back into the sky or returning to the Earth, continuing its endless, flowing journey. You are not holding the water. You are simply a temporary resting place for the moving rivers of the world. The same beautiful truth applies to the very air in your room. When we explored the delicate, microscopic balloons of your lungs, we saw how you draw in oxygen and release carbon dioxide. But where did that fresh oxygen come from? It was not manufactured in a sterile factory. It was exhaled for you. Thousands of miles away, perhaps in a dense, quiet pine forest covered in morning mist, or deep in the Amazon, towering trees have been quietly standing in the sun, absorbing light and breathing out the very oxygen you are taking in. Even more of it comes from the ocean, where trillions of microscopic, floating plants, the phytoplankton, drift silently in the cold currents, breathing out the invisible spark that fuels your internal fires. They offer the oxygen to the wind, and the wind carries it across the world to your open window. And in return, your quiet, rhythmic exhales release the exact carbon exhaust those distant forests need to build their thick, wooden trunks and stretch their leaves toward the sun. It is a massive planetary respiration. Without ever leaving your bed, you are physically tethered to forests you have never seen and oceans you have never touched. We can look, too, at the heavy, tangible substance of your body, the proteins, the fats, and the deep structure of your bones. We know they came from the food you ate, safely dismantled in the warm bath of your stomach. But long before that food reached your plate, its raw materials were pulled from the quiet, dark soil of the earth. The soil is not just lifeless dirt, it is a brilliant, living memory. It is made of generations of fallen autumn leaves, ancient trees that slowly surrendered to the forest floor, and quiet creatures that returned their borrowed architecture to the ground. Fungi and gentle bacteria spent decades breaking those fallen lives down into clean, rich nutrients, waiting patiently in the dark until the roots of a new plant reached down to gather them up again. The calcium in your bones, the iron in your blood, and the deep carbon of your cells were all drawn from this recycled ancient dust. You are quite literally built from the earth, assembled from the quiet ruins of everything that has ever lived before you. In our modern adult lives, it is so incredibly easy to forget this connection. We spend our days commuting in heavy traffic, looking at the glowing screens of our phones, paying bills, and walking through climate-controlled buildings. In the busy, artificial environments we have built, we can begin to feel deeply isolated. We can look out at a quiet forest or a sprawling ocean and think of it as nature, as something completely separate from us, something outside of us, something we only visit on a weekend. But biology quietly and firmly reminds us that there is no outside. You cannot be separated from the biosphere any more than a single, rolling wave can be separated from the ocean. You are a natural, beautifully complex, and entirely necessary expression of the earth. The same quiet forces that govern the slow drifting of the continents and the changing of the seasons are actively governing the slow, steady beating of your heart. You belong here. You are woven perfectly, flawlessly, into the ancient fabric of life. And so we come to the end of our time, with the story of biology not an ending, really, but a place to rest. We have traveled from the deepest, microscopic vault of the cell to the sweeping, protective skin of the entire world. You have let these heavy, beautiful ideas settle beside you as you rested, and they will be here whenever you wish to return. There is nothing left for you to manage tonight. The brilliant, folded engines of your cells are burning quietly. Your immune system is walking its silent patrol. Your heart is keeping its steady, ancient rhythm. Your body knows exactly what to do. No tests, no grades, just a quiet sense that you understand a little more about the miracle of your own existence than you did before. Until then, sleep well and carry nothing but that.